Hi everyone. So good to see you all in a new topic, new section. So that is grippers and robotic design. Okay. I'm Aiswarya, working as an assistant professor in the Department of PCE at Emmanuel College of Engineering. So let's go into the section. So grippers. Grippers is nothing but it is an important part of robotics that helps the robot interact with objects in the real world. Okay, so they help the robots to interact with objects in the real world. Okay, so robots cannot perform the task alone. Okay, they need tools called end effectors. So grippers are the most widely used end effectors. Okay, so robots can be used only along with the end effectors. So for the end effectors, the grippers are used as the end effectors. So they help robots pick, hold, and move objects accurately, especially in industries. Okay. So grippers are the hands of robots enables interactions with physical objects. So they are critical for automation and manipulation tasks. So as I already told, devices used for grasping or manipulating the objects act as a robot's hands. Okay. So attached to robot's wrist. As we all know, what is human hands and human hands having wrist, right? So how they move according to the rotation path, how we need to take the object from a place using our fingers, right? So by that same process, the robotic hand also needs some hands for wrist movement. Okay, for that these grippers are actually used. Okay, so let me say once again, grippers are the most widely used end effectors because only by using an end effector the robot can perform the task. Okay, so the robot helps pick, hold, and move objects accurately by using this grippers. Okay, so a gripper is a device, okay, that attached to the robot's arm. Okay, gripper is nothing but it is a robotic arm. It works similar to the human hand. I have explained already. So it works as same as a human hand, and it is used to grab the objects. I told you the human hand using the fingers we use to grab some things, isn't it? So by grab these things, we need the wrist movement, isn't it? So the same we need grippers here. So it converts control signals into mechanical movement to hold items securely. So what is the main process happening here is it controls the control signal into mechanical movement to hold the items securely. Okay. So some fundamentals are there. With what types of force, what type of precisions are used here? See, the force is sufficient to hold objects securely. The force which is given to the gripper is very much sufficient for holding the object securely. Then the next one is the precision. That is accurate positioning and control. Okay, accurate positioning and control. Without accurate, even if you think about a human being, it has thinking capacity and the brain gives signals to the hand that we have to take this object from this place. That is, we have to hold. For example, by holding a glass bowl, we should be very careful, isn't it? Or else what happens? If the grabbing, if the grip is not there, the glass bowl may fall down and get damaged, isn't it? So like that, for that the brain will give the control, right? Give the signals to the hand, like hold it tightly because it is a glass ball, may fall down and get broken. So handle it. So grab it, grip it clearly, and you move to a other place. Okay, like that, the robot may get also a control. A controlling signal which can be moved into a mechanical movement by using certain force, precision, speed, and adaptability. It can fold like a finger and it can move like a wrist, and it helps the what? Robotic arms to move a object from one place to another. So that is what the force it is sufficient to hold the object securely. Then it is precision, that is, it is accurate position and control. Again, speed, that is, it has a rapid response effectively, and adaptability, that is, it handles various shapes and size. See, as we know, we can handle a small ball with one hand and a big vessel with two hands. This is just like human. But the robots, they can carry heavy and more light objects, isn't it? They do not need, as Shaipan said, any shapes and size without any problems. Then functions of grippers. See, the main functions are it picks and place operations, holding objects during processing, assembling the task, sorting and packaging. So main process is what? Pick and place operation. Next one is holding objects during processing. Next, assembling the task. Then sorting and packaging. So, for example, let me explain you. If you are a human, you are going to your task is you are going to paint a bowl. Okay. So what will you do? First, you will pick the bowl in your hands, isn't it? Then you will hold the object while painting it. Then you will assemble. If you want to make some pieces to get joined with that, or you have to do some decoration work, you will assemble it, right? Then sorting and packaging. What type of bowls should come under one section? That means sometimes a white colored bowls can be kept aside, and the black color designed bowls can be kept aside, right? So like that you can sort them and you can pack them accordingly. Okay, so that is the function what a human being do according to a task. Likewise, the grippers may also have the certain functions, that is pick and placing the operation, then holding the objects during processing the work, then assembling the task, then sorting and packaging the process. That is, grippers are mainly used for pick and place operations. They also hold objects during manufacturing processes and help in assembling parts. Okay, they are essential for material handling in industry. They are mainly used for material handling in industries. Okay. Again, types of grippers. Okay. There are different types of grippers designed for different purposes. As we know, different types of grippers are used for what? Different types of works, isn't it? So, the main types include, what are they? Mechanical grippers, vacuum grippers, magnetic grippers, adhesive grippers, and soft grippers. Also, there are many varied varieties of grippers are there, but for us, the very important types of grippers are these five. Okay, let's explain them deeply and look into the sections. Okay, the first type is mechanical gripper, then vacuum grippers, magnetic grippers, adhesive grippers, and soft robotic grippers. Come, let's see the first one, that is mechanical grippers. See, mechanical grippers are the most commonly used. Okay, as for we have explained it in the first itself. That is, the main work we do is it controls the it converts the control signal and into a mechanical movement to perform certain tasks, isn't it? So that is what the mechanical grippers, 2-finger grippers and 3-finger grippers, so parallel jaw grippers are there. Okay, and mechanical grippers are most commonly used. They usually have 2 or 3 fingers. These fingers open and close to grip the object. Okay, these fingers. Okay, there may be 3 types. That is 2-finger grippers, 3-finger grippers, and parallel jaw grippers. Okay, so the 2-finger grippers and 3-finger grippers are used to what? Grab the object. These fingers open and close to grip the object. As we know, only by opening and closing we can grab a thing, isn't it? So they are very accurate but not suitable for delicate items like fruits. Okay, so these are mechanical grippers, isn't it? By the name itself, a metal-like thing, a heavy object-like thing, can it use it to hold fruits or vegetables like that? No, definitely no. So that's what given is. It is very accurate. Okay, it's very accurate and is most widely used, but it is not used for delicate items like fruits and vegetables. Okay, so the 2-finger grippers, they are simple and versatile. Here you can see a picture, right? This is a 2-finger gripper. Again, 3-finger gripper may be also there. That is better object stability. If you can imagine by using a 2-finger, you can hold a simple thing, isn't it? So, but if you use 3 fingers, you can grab a whole big sized bowl very accurately, isn't it? That there the better object stability is better, isn't it? That's what that's mentioned here. Again, next one is parallel jaw grippers. They are precise and compact. Okay, parallel jaw grippers, they are precise and compact. Then the most common types are the 2 fingers and the 3 fingers. Okay, they are actually used by actuators. Okay, what is actuators? We will go further and we will explain. Okay, so they are mainly used by using the actuators. Okay, so types of mechanical grippers are parallel grippers, 2 finger, 3 finger, again angular grippers and internal grippers. Okay, so parallel grippers, angular grippers and internal grippers, they are the main 3 types of mechanical grippers. Okay, next is the vacuum grippers. Okay, so vacuum grippers are used suction to pick objects. We all know what is suction, isn't it? So they suck some things and take it from one place to transport it into the another place. So that what vacuum grippers use suction to pick objects. They are commonly used in glass handling and packaging industries. However, they work best on smooth and flat surfaces. Okay, so vacuum grippers, they use suction cups. Okay, so we know the suction cups, vacuum cups. So there, what will they do? They suck the object from one place and it can transport to another place. Okay, so as per we know, these types of robots are mainly used in where glass type of industries. Okay, because the glass, they may be very delicate, they may be very, we have to handle them very carefully, isn't it? Because if it may fall down while handling, there is a big glass piece will be used to transfer from one place to another with the help of 5 or 6 numbers, isn't it? So what will happen if one might have drop it? It may fully damaged, isn't it? But if a robot is controlled mechanically or electrically using these type of grippers, they will hold them tight without any problem and can move from one place to another very easily and safely, isn't it? So for that, these vacuum grippers are used. Okay, these uses suction cups to grip the object. Grip means to hold the object slightly. Then it is ideal for flat and smooth surfaces. Okay, it is mainly used for smooth and flat surfaces. Again, it is mainly used in packaging and logistics. Okay, packaging industries. It is mainly used in packaging industries. As per the picture, you can see, right? See here, this is the, here where the suction cups, the vacuum grippers are there. There you can hold the water bottle and it is moving from one place to another. Like this, it can be used in glass industries also. Okay. Next is the magnetic grippers. Okay. So as per now, we have seen 2. One is mechanical grippers and next one is vacuum grippers. Now the third one is the magnetic grippers. Okay. So the magnetic grippers use magnetic force to lift metal objects. Okay. So what is this magnetic grippers use? The magnetic grippers use magnetic force to lift metal objects. These, they are very fast and efficient. Okay, they are very fast and efficient, but can only be used for ferromagnetic materials like iron or steel. Okay, they are used for magnetic lifting. Okay, metal objects, you want to lift some metal object by using this magnetic gripper, it can be used. But what is the main thing is it can only use for ferromagnetic materials. What is ferromagnetic materials? The ferromagnetic materials are actually iron or steel. So only these 2 metals can be used to move from one place to another using this mechanical using this magnetic grippers. Okay, these magnetic forces to grip ferromagnetic items like iron or steel. Then no need for complex mechanical parts. Here, no need of complex mechanical parts as to used in this mechanical gripper. That is 2 finger, 3 finger, metal parts. Metal fingers are not necessary. Okay, just a magnet is enough for holding the ferromagnetic items. Used in metal working and assembly lines. It is mainly used in metal working industries. That is more where the iron and steel, that is the ferromagnetic items means iron and steel metals, where they are mostly used industries, and assembly lines. In some industries, we have to assemble all types of iron metals, all types of steel metals, right? For assembling process, this magnetic grippers are used, and for metal working industries also, this magnetic grippers are used. Okay. So the next one is adhesive grippers. Okay. This adhesive grippers use stick surfaces. Okay, use sticky surfaces. Used for delicate objects. Okay, they are used for delicate objects and inspired by nature. Okay, see, these grippers use sticky surfaces inspired by nature like gecko feet. They are used for delicate items but cannot carry heavy loads. Okay, as per it is given that it can only be used. It can only be used for what? It can only be used for delicate object handling. Okay, it is used in sticky places. Okay, by seeing this picture you can understand this is the adhesive gripper. Okay, this adhesive gripper like gecko feet. Gecko feet means they are somewhat slippery. Okay, sticky surfaces where you can stick. If you hold with this adhesive gripper, the object, the delicate object gets sticked through it and you can hold that very clearly and you can move it from one place to another. Okay, but only few small items can be get hold by this. Heavy metals cannot be hold. Okay. Next is soft robotic grippers. Okay, soft grippers. So next one is soft grippers. The final one, the last one is soft robotic grippers. So the soft grippers are made of flexible materials. Okay, they are made up of flexible. What is mean by flexible? They are very strong. They can be bended, they can be folded, but they cannot get damaged. That is, they cannot get completely broken. That is called flexible. So soft grippers are made of flexible materials. They can adjust the shape to hold fragile objects like fruits or medical items safely without damage. So fruits, vegetables, some medical items, they should not get damaged at any cost, isn't it? If they get a slight damage, then the whole thing is waste in some cases. So they should be handled very delicately. Okay, they are fragile items, so they should be handled with very much care. So for that, the soft robotic grippers are used. So they are inspired by nature, that is octopus or human hands. For example, if we hold a vegetable or fruit, for example, if we hold a carrot, we know a little bit tight can be given. The cat is a little bit strong, it cannot get damaged. But if you hold a grape with the same stiffness, if you hold the carrot and the grapes with the same stiffness, will the grapes get damaged or not? Yes, of course the carrot gets okay, but the grapes get damaged, isn't it? It gets squeezed. So they are like fragile items. That should be handled with very much care. We know, right, about the hands. So by inspired with our hands, these soft robotic grippers are customized, that is designed. Okay, so they are made of flexible, complex materials. That is, they are made up of flexible materials. That is, they can be hold, they can be twisted, they can be folded, they can be bended, but it will not get damaged. Say for delicate and irregular objects. That is, if a shape of an object is regular, we can identify, isn't it? But for irregular objects also, it will hold it tight, it will hold it neatly, and it without any damage, it will transfer from one place to another. See, by seeing this picture itself, we can identify this. This is a soft robotic gripper. This blue color picture, the blue color finger-like structure is a flexible grippers. Okay, so they are holding a vegetable, capsicum, without any damage. They are neatly holding it and transporting from one place to another. Okay, so as per now we have learned 5 grippers, that is magnetic, vacuum, then mechanical, adhesive, and soft robotic grippers. Okay, so the next one is gripper actuation method. Okay, gripper actuation method. The gripper actuation method the gripper operates using different power sources. Okay, they work under different power sources. These are the actuators or the power sources. Okay, there are some types, that is pneumatic, hydraulic, and electric. Okay, so these 3 types of actuation methods are used in this grippers. Okay, so grippers operate using different power sources, and these 3 are the different power sources used for grippers. Okay, so the first one is Pneumatic actuation. Okay, so pneumatic actuation means fast and lightweight. Okay, pneumatic actuation means fast and lightweight. They use compressed air. Okay, this pneumatic actuators actually uses compressed air. They are fast, lightweight, and commonly used in industrial automation. Okay, they are mostly used in industrial. As per the picture, by seeing the picture itself, you can understand it, isn't it? That they can be used only in big industries, because these type of big machines, big robotics cannot be used in any other domestic places. So this can be used only in the industries. Okay, so they are compressed. They use this pneumatic actuator power source used in the grippers, uses compressed air. Okay, they are fast, lightweight, and commonly used in industrial automation. They are the very much useful in industries because they are very low cost. Okay, they are low cost, but what is the problem is it has limited precision. But when we do a process in industries, the measurements, the accuracy, the pointing, everything should be in a very minute and precision length is used, right? But here the precision of this robotic usage is less. So that is the limitation. That is the disadvantages of using this pneumatic actuation. Okay, so it is use compressed air. They are fast, lightweight, and commonly used in industrial automation. And its advantages is it is low cost, but the disadvantages is it has limited precision. Okay. Next is the hydraulic actuation. Okay, the hydraulic actuation is the next type of actuation. So this is also a different power sources. So hydraulic grippers use fluid pressure. Okay, the hydraulic grippers uses the fluid pressure. There in this pneumatic pressure, actuation we use compressed air, but here you use fluid pressure and can produce very high force. Okay, and can produce very high force. This hydraulic grippers uses fluid pressure and can produce very high force. They are used in heavy duty applications. Okay, so hydraulic grippers uses fluid pressure and can produce very high force. They are used in heavy duty applications. Okay, heavy duty applications means for highly applications. For high, very heavy load carry process, it can be used. So this is high force output. High force output. Okay, that means it can used to carry heavy objects, and so it has what type of output? High force output can be used, and it is used in complex systems. Okay, so any type of complexity can be handled by this gripper hydraulic actuation. Okay, for heavy object handling, the power source used is the hydraulic actuation. Why? Because it can handle complex systems and used in heavy duty applications. Okay, so the next one is electric actuation. Okay, the electric actuation is nothing but electric grippers use motors for operation. Okay, as we already learned actuators, electric actuators. So electric grippers use motors for operation. Okay, the electric grippers use motors for operation. They provide high precision and can be easily controlled using programming. For the first step, pneumatic actuation, we know the precision is very less, right? But for this electric grippers, the precision is very high. Okay, so it can be controlled easily by programming. By using certain small types of programming changes, the whole system can be controlled. Okay, so it has high precision, programmable control, widely used in modern robotics. Okay, so for modern robotics, they actually used them by controlling them using the programs. Okay, so for that method, this electric actuation is highly recommended. Okay. So up to now we have learned three types of power sources. What are they? Hydraulic, pneumatic, and electric. Okay. So next is the design consideration. What are the design consideration used here? Object size and shape. What should be considered? Actually, what should be considered here is the very important topic. For choosing the grippers, for gripping, for handling, for holding, that should be very much considerable. For using or holding a delicate object or a fragile object, what type of grippers must be used? That should be assigned, or that should be considered very clearly and very carefully, because for example glass is a fragile object, right? For that, if you use the mechanical gripper, the glass might have damage, right? Or else for delicate object like fruits or vegetables, if you choose mechanical gripper instead of soft grippers, what would happen? It is not applicable, right? Likewise, the design consideration must be very, very important in choosing the types of grippers. So the first design consideration is object size and shape. The size of the object, the shape of the object which we need to be used for the task, which we need to be placed from one place to another, that should be considered very carefully. Only because of that, only after considering the shape and size, we can use to choose the grippers. Next, weight of the object should be also considered very carefully. Only the lightweight objects can be held by using the soft gripper. The heavy object should be carried by the mechanical object, isn't it? The magnetic object should be carried by the magnetic grippers, not by the mechanical. So the vacuum products should be carried by the vacuum grippers, isn't it? So that should be considered. Next, the surface texture. If the surface is flat and smooth, what will you use? And it is lightweight, what will you use? We will use soft grippers. If the surface is smooth and the object is fragile, we will use vacuum grippers. If the surface is magnetic form, like metals like iron or steel, then we will use for magnetic grippers, isn't it? So by surface and texture, we can identify the grippers should be used. Required gripping force, the very important thing, for which product, for which item, which type of force is needed. For heavy metals, heavy force should be needed. For fruits and vegetables, a low soft type of gripping force is needed, isn't it? So according to the object's weight, according to the object's size, according to the shape, according to the surface texture, and also according to the gripping force of the object, the gripper should be chosen, isn't it? So this is the main design consideration used here. What is the design challenges? Okay, so for designing that, we have certain challenges facing here. So there is balancing strength and delicacy. Balancing the strength and delicacy, that is very much challengeable here. That is, for an object, the object may be very delicate, right? For the delicate object, it should be balanced properly. The balancing strength should be properly designed. So that is also one of the important things here. Next, the energy efficiency. The energy efficiency is and control complexity. The energy and the complexity of the things should be considered very clearly. Okay. Next, ensuring safety in human robot interaction. So the robots and the human should have an interaction, should be very safely. The safety between the human and robot interaction must be very important, because without that, the controlling of the robot by the human will be very much difficult. Again, the cost and manufacturability. Actually, we know for robots, the initial cost is very high. The manufacturability should be high according to the initial cost. But if the initial cost is high, the production is high, and the manufacturing method is high, but the demand is less, then it is not useful, right? So the cost and manufacturing rate should be equal ratio, okay? So we should get known with all these challenges. We should face all these challenges, and we have to design the grippers to overcome the differences in this designing of grippers, okay? Again, importance of friction. This is gripping force analysis. Next is gripping force analysis. As I told you, for design consideration, the gripping force should also consider, isn't it? So the gripping force consideration, that is first one is the importance of friction. The friction, right? The holding friction, some friction, pressure, that should be very much considered. The importance of friction is very, very important in gripping force analysis. Again, the force calculation basis. Okay, the force calculation basis means how the force should be calculated. That is, what type of force, what type of pressure is needed on holding a certain object. For example, for holding a bowl, a small glass bowl, a certain pressure is needed. A certain force is given to the gripper. But by holding a vegetable or fruit using a soft gripper, less force or comparatively less force or less pressure is needed, isn't it? So the force calculation is a very basic. Next, safety factor. As I told you, first of all, for holding a fragile object like a glass and also holding a heavy metal object, or comparatively holding a small fruit or vegetable, which everyone needs, everything needs a certain type of safety factors according to them. Okay, so there is no need of calculating the safety factor only for one object, and we can recommend that gripper to that object, because each gripper has different types of safety factors concerning to the same methods that are used for that product. Okay, so the main gripping force analysis are importance of friction, force calculation basis, and safety factor. Okay, so the first step here is each instrumented beam measures a set of orthogonal process. Okay, that is the first picture. See, first one. The next one is the orthogonal vectors are resolved for each instrumental beam. The given the set of orthogonals are resolved for each instrumental beam. Okay, then it is again given to overall resolved grip force vector. The overall grip force factor is then calculated totally. Then the grip force vector with magnitude and angle theta is calculated. Okay, for calculating the gripping force analysis, we need magnitude F and the angle theta. Okay, materials used in grippers. The materials is actually steel and aluminum. Okay, so the grippers can be used with certain types of metals, so that are steel and aluminum. Then for rubber means, for what rubber is used? For holding that very grip. Okay, for that grip they are using rubber, and in some process they are using polymers also. Okay, so the materials used in grippers are metals like steel and aluminum. Then for rubber they use for some grip, and then in some cases polymers also used. Then sensors used in grippers. Some types of sensors are also used in grippers. Why sensors are used in grippers? Because they sense the object size, shape, humidity, temperature, and so that the forces can be applied to the certain object using the certain grippers can be easily calculated. Okay, by only them this sensors can be calculated. Okay, so the sensors in grippers are force sensors, tactile sensors, proximity sensors. Okay, the sensors are force sensors, tactile sensors, and proximity sensors. These sensors are highly recommended in grippers, because only by using these sensors, what happens? The object should be handled very carefully by the grippers, because only the grippers know how to hold the objects. Okay, so by using certain sensors only, what happens? This can be used. Okay, then tactile sensors. The tactile sensors, for what it is used? The force sensors in robotics enables machines to detect, measure, and react to physical contact, providing essential feedback for tasks requiring precision, safety, and adaptability. Okay, so the force sensors, which is used to enable machines to detect, measure, and react to physical contacts, providing essential feedback for tasks requiring precision, safety, and adaptability. Okay, for these things these four sensors are used. Okay, so these are used for measuring all these things. Okay, so next one is tactile sensors. So this tactile sensors is nothing but this replicates human touch, allowing robots to precise pressure, force, texture and shape during physical interaction. Okay, so the tactile sensors are nothing but they are replicate, that is they can replicate us like a human touch. By a human touch, what can be you can predict pressure, the force, texture, shapes, isn't it? So all these can be replicated using this tactile sensors. Okay, so the tactile sensors in robotics replicate human touch, allowing robots to perceive pressure, force, texture and shape during physical interaction. Okay, so the next one is the proximity sensor. Okay, proximity sensor. So these proximity sensors in robotics are non-contact devices that detect the presence, absence or distance of objects. Okay, once again I will explain. Proximity sensors in robots are non-contact devices that detect the presence, absence or distance of objects. So it cannot be contacted. This proximity sensor cannot contact with any of the devices, but it detects whether the object is present or absent or the distance of the object from the gripper. Okay, this is mainly used for automation, safety and also in navigation. Okay, so this is used here. This technology, this proximity technology can be used in infrared, ultrasonic, capacitive or inductive. Okay, they even allow the robots to avoid collision, detect parts and interact safely with the environment, enhancing efficiency and preventing wear. Okay, so this proximity sensor is very much advanced sensor. Okay, it is a non-contact sensor which is but detect the presence or absence or the distance of the object. Okay, which can be used mostly in automation, safety engineering and in navigation also. Using this technologies, infrared, ultrasonic, capacitive, inductive sources can be detected and even it helps the robots from collision, detecting the parts in front of them and interact with the environment safely without any efficiency defect. Okay, so the main application of this the main application of this grippers are, in addition to industries, grippers are used in medical robots, agriculture for fruit picking and service robots for daily tasks. Okay, you can see in many videos that many large manufacturing industries of fruits and vegetable jam making and processing, there they are used to pick fruits, isn't it, by using robotic machines. So there it is widely used. Okay, so in industrial automation it is used for assembling and packaging, as we have defined in the first mechanical grippers itself. Then in healthcare it is used as surgical robots and prosthetics. Okay, so surgical robots, the robots itself they use as a surgeon. Then service robots for food handling and household tasks. As I told you, food handling is nothing but the process of fruit picking, vegetable picking, like that in that type of manufacturing industries. Then for household tasks also, for domestic services also. Then in space exploration, the robotic arms on spacecraft. The spacecraft for using spacecraft, the robotic arms are also used. Okay. So the modern grippers are becoming smarter with AI and sensors. Okay, nowadays the modern grippers are becoming very much smarter with artificial intelligence and sensors. Soft robotics is also growing. Okay, soft robotics is also growing, allowing safer interactions with the humans. Okay. Then the advantages of grippers are their automation efficiency. Okay, their automation efficiency. Then they have precision handling, reduced human effort. They have reduced human effort because using these grippers, the human effort can be reduced in all type of things, right? So precision handling, even human can make mistakes, but using the precision programming control, this can be handled very easily. Then automation efficiency, the efficiency can be used very high rate. But they have certain limitations too. There is limited adaptability, that is traditional grippers. Traditional grippers, it has limited adaptability, okay? It cannot be adapted to all the environment. Then the cost of advanced system. As I told, the modern grippers are becoming very smarter, but the advanced system, they are very cost, okay? They are very high in manufacturing cost. Then maintaining them is also a little bit of risk, because if they are not continually used with this updation models or smarter AI techniques, the maintaining of the system can be also get collapsed, okay? So these are some of the case studies. We can go into that. There is Amazon warehouse robots for item picking, Da Vinci surgical system for precision gripping, then Boston Dynamics for adaptive robotic hands. Here also, like these industries, many type of industries that use robots for using certain tasks in their industries, okay? The main is Amazon warehouse. There many types of items should be picked and packed accordingly. So for that item picking, these robots are used. Da Vinci surgical system is for precision gripping, okay? So precision is very much important in gripping an object. So there, the surgical system that is used. Then Boston Dynamics, adaptive robotic hands, okay? Adaptive robotic hands are used for Boston Dynamic industry. Future trends, AI-driven adaptability, okay? Future scope maybe will become more intelligent and flexible, okay? In future, the grippers will become, we have seen what types of grippers are used, for what purposes different types of grippers are used, what types of powerful sources, that is the different types of actuators in using grippers we have explained. Then what is grippers, how they are used along with a robot to interact with a human in day-to-day life to do certain tasks, isn't it? So by all these things we can come to a conclusion about the future of the gripper in robotics, isn't it? So in future, grippers will become more intelligent and flexible, okay, with human-like abilities and better safety in human-robot interactions. This can be used very effectively, okay. So in future, the grippers will become more and more intelligent and flexible, okay, with human-like abilities and better safety in human-robot interactions, okay. So by this, I would like to conclude about grippers. That is, grippers are vital in robotic systems, okay. Grippers are essential components. They're very much essential components of robots. Their design actually depends on the task and advancements which continue to improve their performance, okay. So their designs involves trade-offs and innovation. Innovation means new things that should be formed regularly, isn't it? Then their design depends on task and advancement will continue to improve their performance. Okay, advancement will continue to improve their performance. So grippers are vital. It's very essential in robotic systems. Designs involve trade-off and new innovations. Future holds smarter, safer and greener grippers. Okay, they should be environmental friendly too. That is what's mentioned as greener grippers. So they should be smarter, safer and greener grippers. Okay. So I hope you can all understand what is about grippers, what are the types of grippers and everything. So let's wind up this section. If you have any doubts, please do comment in the commenting section. Okay. Thank you.